In this video, we're going to answer the following question. Okay, given that we have a square of length A, so assume that A is bigger than 0. We accept that something has 0, but that's mathematically speaking, but let's be real. Let's assume that A is bigger than 0. So we claim that if you take any 5 points from the square, let's say here, 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 or maybe here, 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 the 5 points, and if you measure the distance between any two, you find that it's less than A over 2. Okay, this is true. Yeah, but someone might say, okay, I can find points. Okay, I can find points here in the corner. Okay, and the distance between the two is, in this case, it's exactly A over 2. Okay, but 5 of them, if you get 4, no, it's not possible. Okay, so 4 points, I can get this one. The distance between this one and this one is A. This one, A. And I can prove that if you pick 4 points, you can't always find some distance that's less than A over 2. But if you pick 5, so let's say this is the extreme case. So all the points in the corner and one is in the center. Okay, so my statement is true. So if I pick any 5 points, I can find 2 such that the distance between them is less than A over 2. Okay, but someone might say, okay, let's pick these 4 points and let's get this one. So here, the distance here is bigger than A over 2. This is bigger than A over 2. But this one is less than A over 2. Okay? If you pick it here, it's less than A over 2. If you pick the 5th point, so this is the critical point. We need 5 points. So this one, this is the point that helps. Okay? Let me draw this one here. Okay. So this is my square. So if I assume that I pick the points here, a 5th point, okay, can be anywhere. But the distance between this point, one of the points, and my new point, the 5th one, is going to be less than A over 2. Okay? But in general, to solve this problem, I'm going to split my square into 4 small equal squares having side length A over 2. So this is A over 2, 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 and this one is A over 2, this one is A over 2, this one, everywhere. So it's a square. Okay? Now, if I pick a point here, okay? So I want to pick 5. Pick one here, one here, one here. Any other point, the 5th one that I pick, would be less. The distance between the 4th point and the 5th point would be less than A over 2. Okay, so this is how we do it. So what I'm using is the pigeonhole principle. Okay, so the pigeons in this case are the points. I'm gonna call them P1, P2, P3, P4, P5. And these squares, I'm gonna do them as the holes. Okay, so let's call them hole 1. So this is the squares, calling them hole 1, hole 2, hole 3, hole 4. If I pick one, I can put it here in this square. This one and this one. This one here. This one here. The 4th one, this 5th one, I can put it in some other one. So everywhere I put it in one of these 4 square, the distance between P1 and what's this one, P4, is always less than A over 2. Okay, so this is the pigeonhole principle. Basically, you need to find the pigeons and the holes. Okay, like in our case, we are given the pigeons. We need to find the holes. So that's why we had to construct the holes using the square. Okay, so the pigeonhole principle is a constructive proof-based principle. That means you need to add something, you need to create something, okay? And think of it as function, okay? You need to create something from yourself. You are not given everything. You have to add something from, you do it, you add something. Either you have the pigeons or the holes, or maybe sometimes in some creative problems you don't have both. You have to create that by yourself. I hope that you see what we mean when we say the pigeons and the. Another thing is that the pigeonhole principle in discrete case states that if we are given a function that's going from a set A into B, such the cardinal of this set is n, and the cardinal of this set B is m, and n is bigger than m, then we can always find some number, some two numbers, let's say x1, x2, such that f of x1 equals f of x2, with x1 different from x2. Okay, we can find two pigeons that would go to the same hole. So it's like this. You have three, you have two holes. Either you're gonna have this one go this one gonna go here, and this one has to go this one. Has to go to this side. Okay, the function has f has to be surjective to eliminate all those cases. Okay, to eliminate every case. We're gonna come back to this one. Anyways, this solve this problem that we have.